Hello friends and welcome at my channel. Today let's see how the graph of x squared plus 2 divided by x looks like. Okay, so we start with the very first step, which is domain. Once again, x isn't allowed to be 0. It's pretty simple by hyperbolas. If x is 0, in the denominator is a problem. Number 2, any kind of symmetry. Well, let's compute f of minus x, which is minus x squared, plus 2 divided by minus x. So it is x squared minus 2 divided by x. Well, obviously is not equal to f of x. And what about minus f of x? Well, you see it's going to be minus x squared plus 2 divided by x. So we're going to have minus x squared minus 2 divided by x. Not equal. All right, so no symmetry whatsoever. No simple symmetry, we call it this way. What about limits? Well, if x runs towards infinity, you see the fraction is disappearing because if x is huge, it's not existing. But what about x squared? Well, it is very big, infinitely large, so it's plus infinity. What about limit x towards minus infinity? Once again, the fraction is disappearing. X squared makes it positive again. So now, what about limit x towards 0 from the right-hand side? Well, if we approach it, so this is almost 0, it's not interesting at all, but we are dividing by a very tiny positive number, so the outcome is huge positive, so plus infinity here. And what about limit x towards 0 from the left-hand side of f of x? Well, you see, x squared is disappearing again, and 2 divided by x, we're dividing by a very tiny negative number this time, so the result is minus infinity. That's the story. Number 4. 0 points. Well, x squared plus 2 divided by x equals to 0. What can we do? Well, we can multiply the whole stuff times x. We're going to get x cubed plus 2 equals to 0. X cubed equals to minus 2. Now we take a cubic root. So x, only one cubic root here is the cubic root of minus 2, which is possible to compute, by the way, right? Would be a problem in high school mathematics without complex numbers if we would have the 4th or the 6th root, but not the case here. All right. Number 5, extreme values. So what is f prime? F prime is 2x minus 2 divided by x squared. Let's put it equal to 0. We got 2x equals to 2 divided by x squared. I can multiply times x squared. We got 2x cubed equals to 2. We divided by 2. We got x cubed equals to 1. So x is the cubic root out of 1, which is 1. And I would like to compute points of inflection as well. So we are also computing the second derivative here, which is 2. Now, remember that 2 divided by x squared can be written as 2 times x to the power of minus 2, which I'm having here. I'm also having minus, so this is like that. Minus 2 is coming in front, so we are having 4 times x to the power of minus 3, or basically 4 divided by x cubed. All right, if we're plugging in 1, f second prime at 1, going to be 2 plus 4 divided by 1 cubed, so in any case it's positive. So what do we have? We have a min. All right, we have a min at 1, and what is the y value of the min? I'm putting it into my original function right there. So this is 1 plus 2, it's 3. So 1, 3, this is the graph. This is the minimum totally given with all the coordinates. All right. Points of inflection, number 6. 2 plus 4 divided by x cubed should be equal to 0. So 2 is equal to minus 4 divided by x cubed times x to the power of 3. 2x cubed equals to minus 4. I'm very detailed in this step, but it's all right. Now we're dividing it by 2. We're going to get x cubed equals to minus 2, and we're going to take cubic root out of that. and x, once again, just only one value is a cubic root of out of -2. Let me check if everything is all right. Seems to be fine. So was that the same as the 0 point? And the answer is yes. All right, so the 0 point and the possible point of inflection, I have no guarantee yet that this is a point of inflection. I need to actually produce the third derivative, which I'm doing here. So 2 is disappearing. We have 4. This is 4 times x to the power of -3. It's coming down. We got -12 x to the power of -4, or -12 divided by x to the power of 4. Now plugging in the cubic root out of -2 gives us, well, I don't need to have the value necessarily. So this is the cubic root out of -2 to the power of 4. That's right. So I don't care what's happening here. To the power of 4 is giving positive, so it's a negative value for sure. I cannot simplify anything, well, which would be fine. But most important, it's not 0. So we have point of inflection I with the cubic root out of -2 as an x value, and well, I know it's a 0 point, so 0 as well. All right, so there we go. Now we have to plot the graph. This is step number 7. So let's see what's happening. What do we know? First of all, 0 point somewhere here, which is a -2 cubic root out of that. All right. Then at 1, 3, we have a min. Then approaching 0 from the right-hand side, we were exploding. And it goes like that. All right. We do have a point of inflection. If we're approaching 0 from the left-hand side, we are going to -infinity. So we're somewhere here, low. And this is a point of inflection. We're going to +infinity. So I think it goes like that. Could it be other way around? No. Why not? Well, you see, the point is, if I would have a different point of inflection, different way of a point of inflection, if my curvature would be different, then I couldn't approach the y-axis here, which I need to do because of the limit at 0 from the left-hand side. So this is the graph. I once again make a picture of this. It's not Michelangelo masterpiece, but I'm trying to get there. So this was x squared plus 2 divided by x. Thanks for watching, and see you in the next video.